Good day and welcome to my YouTube channel, Amateur Francis Diban. Today we are going to be having determination of the number of water of crystallization and its percentage. Now, in water of crystallization, if you've done your acid, base and salt, you realize that we have some compounds or substances or salt that contain water in them. While there are certain salt that when you expose them to the atmosphere, they lose a great deal of water from them. So those ones, we call them the efflorescent compounds. Efflorescent is the process. Then we have those who absorb so much to become a solution. They are deliquescent. And there are some that absorb to become moist. They are called hygroscopic. So in our business today, we want to find out, how do we know the amount of water present in a given salt? And how can we determine that? So for us to do that, we use titration in most cases to run the process. Then when we're done with our normal titration, because the amount of water therein doesn't participate in the titration effectively, so we have to use our formula method to determine the number of moles of water present in it. Let's take, for example, if we're having something like disodium trialdehyde 4 got XH2O. The X here is the unknown molecule of water present in the salt. Now, if we have determined the value of X and we presume or understand it to be like 7, for example, and this becomes CO3.7H2O. This 7 means there are 7 moles of water present, and the compounds now become disodium trialdehyde 4 heptahydrate. If it is 5 pentahydrate, if it is 10 decahydrate, and so on and so forth. So that is how we determine that. Now we have formulas, statutory formulas, which we use. And it is imperative, if you can't remember all the formulas which we've done so far, you have to go back to our second video. We have all the formulas enumerated there. Without the formulas, you can't survive it. Because in the course of solving one question, you may end up using more than 4 or 5 formulas to resolve one question. So if you do not have effective knowledge of the formula procedures, you're going to miss it all out, because you will see, like we will proceed further, in the course of solving, you will see that we're going to make use of a whole lot of formulas. Let's take, for example, this is our formula for water of crystallization. We say that relative molecular mass of hydrated compound, the mass com of hydrated is equal to relative molecular mass of anhydrous over mass com of anhydrous. Now, I have to explain the hydrated and the anhydrous. Let's take, for example, I have my disodium 2CO3.7H2O. This is disodium trialdehyde 4 heptahydrate. It means it contains 7 moles of water of crystallization in it. So this compound is hydrated because it contains a lot of water in it. But when we take out the water out, we are left with this sodium trialdehyde 4. We call it anhydrous, which means it does not contain any amount of water. So in our business today, when we are talking of relative molecular mass of hydrated, we're referring to all of this. The mass com of the hydrated means we're going to calculate that. The relative molecular mass of the anhydrous, which is this part alone, and the mass com of the anhydrous. So in both cases, one of them must be given. Then we are going to look for the other one. So we're going to start with our question. Like we do it always, after the question, I don't write the questions, but we have our given. So from the given, we'll be able to know what is required. The question says, solution A contains 20 grams of ethane diol acid crystals. Ethane diol, that is an acid. Now, crystals in 1 dm cube of the solution. Remember, they said 20 grams in 1 dm cube, which means it is what the mass concentration. So your knowledge of the various units must be vast. Otherwise, you're going to be having issues. Now, crystals in 1 dm cube of this solution, 41.63 cm of A require 25 of B for complete neutralization. And solution B contains 0.5 mole per dm cube of sodium hydroxide. From our result, we should calculate the concentration of A in mole per dm³, number of water of crystallization in 1 mole of ethane diode acid crystals, percentage by mass of water by mass of percentage by mass of molecules in 1 mole of the acid. Equation of reaction. Okay, luckily they gave us the equation of reaction. Maybe in subsequent classes I am going to just deal with balancing of the chemical equations, but in this case they gave it to us. Lucky for you, if they happen to give it to you. If they did not, you know what to do. So let's take out the given now. A is always for acid, and B is for our base. So let's start with A contains 20 gram. So here I have 20 gram per dm³. That is the mass form of the acid. And what is the acid? Ethane diode acid. H2C2O4. That's our acid. Crystals in 1 gram of the solution. 41.63 of A, which means the volume of the acid, BA, is 41.63 cm³ of A. Required 25 of B. Volume of the base is 25 cm³. 25 cm³ of B for complete neutralization. And solution B contains 0.5 mole per dm³. B contains CB of the base is 0.5 mole per dm³ of the B. And the B is sodium hydroxide, NaOH. So what and what is not required? We do not have our Ca, we do not have our Na, we do not have our Nb. And the mass concentration theory, if required, we will see. So they also give us the equation of reaction here. So let's take it just to determine our Na and our Nb. H2C2O4 dot XHO give us 2 sodium hydroxide this is the base plus sodium hydroxide, which give us like sodium carbonate plus 2 moles of water plus X water. Okay, that is that. So from here we'll be able to determine our mole ratio. The acid here is 1 mole, the base is 1 mole. So we put our number of moles of acid now becomes 1. Number of moles of the base is now 2. So from here we can proceed further, even if I have to clean this. So the major reason why they have to give us this, so we're able to establish our Na and our Nb. So let's proceed. Now, question number 1. Let's say we should calculate the concentration of the acid in mole per dm³. Now, what's the concentration of the acid? They've given us that of the base. We don't know that of the acid. So from here, you realize that molar concentration of a substance, we have various formulas. Like I said, the CAVA formula is there. And we also have molar concentration equals to mass con over relative molecular mass. Now, we can't use that because what they gave us here is of the hydrated compound. Let me just add the hydrated complete. Dot XH2O. So the mass con given is for hydrated. So we're going to look for that of the anhydrous. So because of that now, the only way we can go about it is to use our CAVA formula. So I have my CAVA over CBVB is equals to Na over Nb. I'm looking for the term of the acid. So my Ca is equals to CBVBNA over VANB. Now, my concentration of the base is given to be 0.5 mole per dm³. 0.5 mole per dm³ times volume of the base is 25 cm³. 25 cm³ times number of moles of the acid is 1. All over volume of the acid is given to be 41.63. 0.63 Cn cubed times number of moles of the base Nb is 2. So when we take out the Cns with this, we are left with mole per dm cubed. So let's proceed further. Now 0.5 times 25. Okay, we have 12.5 mole per dm cubed over 41.63 times 2. 83.26. So finally, 12.5 divided by 83.26. What do we get?
0.157.
Yeah, let's put it here. 0.150 mole per dm cubed. So we have gotten our Ca. Our Ca now, we can now replace that by putting our 0.150 mole per dm cubed. Now we'll look at the next question. The next question says we should calculate the number of water molecules in 1 mole of ethane dioxide acid crystals. So we want to find out what is our X. So remember, for us to get X, we have a formula which we use. So I will state it out. So we're dealing with our B now. B, number of moles of water of crystallization. We have relative molecular mass of hydrated acid, which is ethane dioxide, over mass ton of hydrated acid. This is equal to relative molecular mass of anhydrous, okay, acid over mass ton of anhydrous acid. Now the acid crystals means it contains that water crystallization. So having seen from here, we can get our relative molecular mass here. Fine. Mass ton of hydrated is also given 20 grams per dm cube. Now relative molecular mass of anhydrous, we can get that from here. What about the mass ton of anhydrous? Now we can't get that. So because of that, we have to find out. Now, what is the anhydrous crystals here, or acid, is H2C2O4. This is anhydrous. It does not contain water. So now I want to find out the mass ton of the anhydrous acid. Now we have mass ton equals to molar count times relative molecular mass. Now we know our Ca. From here we have calculated that the molar count times the relative molecular mass of this, we can also determine that. So let's proceed by getting that. So I have to get the mass count, then substitute it into the formula. So let me call it Bi. Mass count of anhydrous acid, which is molar count times molar mass of acid. Now the molar count is 0.150 mole per dm cube times relative molecular mass of H2C2O4. This is 0.150 mole per dm cube times hydrogen is 1 times 2 is 2 plus carbon is 12. 12 times 2 is 24 plus oxygen is 16 times 4 is 64. So 64 plus 26 is what?
90.
90 times 0.150.
13.5 GDM.
13.5 GDM cube. So that is our mass count of the anhydrous. So let us proceed now. So if I put it here, GDM cube of anhydrous is equals to 13.5 GDN cube. GDN cube means mass concentration. Then I can proceed now to substitute the variables into the formula. Remember, the relative molecular mass of the anhydrous compound is 90 gmol. Don't forget that. So now I want to take out that. We've gotten our mass count of the anhydrous. Oops, I'm taking the formula. Oh, okay. Alright, relative molecular mass of anhydrous, mass ton of anhydrous. So now let me substitute. The relative molecular mass of the hydrated, which is this. Remember, this is 90. So we have 90 plus X water. Water is 18. So X 18 or 18X. Let's leave it like that. Over, this is of the word hydrated. And they gave us the mass concentration of the hydrated, which is 20. Which is 20. Let me leave the GDN cube stuff. We are going to find out how that goes. This is equals to that of the anhydrous. The relative molecular mass is 90 over the mass concentration of the anhydrous. We just did calculated it. It's 13.5. So we have to make S the subject of formula here. So you must also understand the topic very well in mathematics. Change the subject of formula. Maybe in due time I'm going to also upload it here for those who do not have a good background in mathematics. So first of all, we cross multiply. Permit me? Cross multiply. Now what I'm looking for is this X. So I try to keep it at my left hand side. So this times this, I'll have, let me move to this side. Um, 13.5 times this, I'll now have 13.5 open bracket 90 plus X18. This times this is equals to 20 times 90. Now 13.5 times this means I have to expand the bracket by multiplying. So I will have 13.5 times 90 plus 13.5 times X18 is equals to 20 times 90. 20 times 90. So now let's do 13.5 times 90 is what?
1215.
1215.
1215.
Plus 13.5 times 18. 243x is equals to 20 times 90. 1800. Now, making this the subject, I have 243x is equals to 1800 minus 12115. 1215. Good. Now 243x is equals to this minus this is what?
585.
505.
585.
585. I divide both sides by 243. 243. 243. This goes. X is equals to what?
2.4.
2.4 what?
2.4.
Okay, 2.4. Now we've gotten our X, which is the number of moles of water crystallization present here. So this is ethane diol dihydrate because it's just 2 moles of water. So many a time we have to approximate it to the nearest whole number. So but 4 is 6 moles, so we'll leave it like that. So we've gotten our B. Now our C is that all? They say percentage by mass of water molecules. So we have to calculate the percentage of water of crystallization. Now, how do we get the percentage of water of crystallization? Like we've been doing in our relative molecular mass or percentage by mass of compounds when you were in your SS1. You remember too well to get our percentage of water means the relative molecular mass of water over the total compound that contains with water times 100. Check in the formulas you see there. So our x, let me put it somewhere here. Our x is equals to 2.4. So let me clean this now. Now let's know the percentage. Percentage of water of crystallization is equals to X water all over H2C2O4 dot water times 100. And this is X water. What is X? X is 2.4 times 18. That's for this. Over, this is 90. 90 plus 2 times 18 times 100. Okay, 2.4 times 18 give us what?
43.2.
Okay, permit me, let me move to this side.
43.2.
Now, 43.2 over this, this is 2.4, sorry. 2.4. This is also 43.2 plus 90 give you what?
133.2.
133.2 times 100. So the percentage would be now, this times this divided by this is what? $43.2 times 100
4,320.
divided by 133.2. 32.4. This is 32.4%. So we've been able to get the percentage of water that was contained in the ethane diol crystals before titration. So after titration, that's what we run, and we get the actual percentage. So the number of moles of water of crystallization were 2.4, and the percentage of water present in the acid was 32.4. So we'll take our next question. Again, like I said, I'll read it and also put out the given. So from there we can proceed. A is a solution containing 0.1 mole per dn cube triazonitrate acids. A stands for acid. With an average volume of 12.90 cm3, the volume is 12.90. B is a solution of anhydrous triazocarbonate 4 salt. Means the triazocarbonate 4 salt does not have water in it, so they call it anhydrous. So let's see where they are going to. The equation of the reaction they've given to us. If the volume of B is 25 cm3, of course, we should calculate the count of B in mole per dn cube, the count of B in GDM cube. C, given that B contains 3.60 grams of the hydrated sodium triazocarbonate 4 salt in 500 cm3. Now, that is the mass concentration now of the hydrated compound. So they say we should calculate the percentage of water of crystallization. So let's start with our given. Okay, our given, they say A is triazonitrate acid, so this is my given. A is HNO3, and B, what did I say is B? Anhydrous triazocarbonate 4, that is disodium triazocarbonate 4. That's our B. Monitor. So A is 0.1 mole, so the concentration of the acid is 0.100 mole per dn cube. 3 significant figures, don't forget that. Acid with an average volume of, the volume of the acid is also given to be 12.90 12.9, let's call it cm cube. B is a solution of anhydrous, that, and all that. The equation of reaction is also given, I'll bring it out later. If the volume of B is 25, BB is 25 cm cube. We should calculate the count of B in mole per dm cube. So we need our Na, we need our CB, NB. These are not given. So we're going to find out, but they give us the equation of reaction, so that's a good thing. We have 2HNO3 plus disodium triazocarbonate 4. That gives us 2 sodium nitrate plus water, yes, plus CO2. Always remember the state of the whole thing. I don't need to put that down. This is aqueous, liquid, and gas. So from here, we can establish that our number of moles of acid is 2, our number of moles of the base is 1. So first question, what did I say we should do? Concentration of B in mole per dm cube. That's what they want us to get. So we have to get our CB. So for us to get our CB, let's put it here. CB says count of B in mole per dm cube. Remember, molar concentration is equals to mass count over relative molecular mass. Now, we can't use that formula here because the mass count of B is not given. So we have to go to the second formula of molar concentration, which is our CAVA. When we use our CAVA, we realize that almost all the parameters have been given, so it will be easier for us. So we proceed by saying we have our CAVA, our CBVB is equals to NA over NB. So if this is the case, let me move down to this way. I'm looking for my CB. So CB will be equals to CAVA-NB over VB-NA. Change of subject. You should know that by now. If I want to cross multiply, for example, I'm looking for CB. So I'll cross multiply. So I will have CBVB-NA is equals to CAVA-NB. Now I'm looking for CB. I divide both sides by what is close to CB, which is VB-NA. 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 So when this cancel out, my CB is equals to CAVA-NB over VB-NA, which we have here. So you should know how to make the variable of what you're looking for, the subject, whenever you are required to. So in this case, I have to substitute the variables inside. Let me take this out, just showing you how to do it or how we get here. So from here, I move on. The concentration of the acid is given to be 0.1 mole per dm cube times volume of the acid is given to be 12.9 cm cube times number of moles of the base NB is 1. This is all over. The volume of the base is given to be 25 cm cube times the number of moles of the acid Na is 2. So this is equals to 1 times 12.9. 0.1 times 12.9 is what?
1.29.
Divide by 50.
0.0258.
0.0258 mole per dm cube. Your unit. Be careful of it. So that I have my CB, which is 0.0258 mole per dm cube. So I've gotten my concentration of the base. So let's see the next thing. They are asking of count of B in GDM cube. Remember, most of the time they will always give you, this is percentage of water of crystallization. They give you the mass count of the hydrated. You look for the anhydrous. And now, according to the question, they give us anhydrous compounds. We want to get the mass count of the anhydrous. As we proceed further, we'll see how they will bring all the questions all together. They can get us confusing sometimes. So let's proceed. Mass count of the anhydrous. That is the GDM cube. Now let's proceed. I want to clean this. If you permit me. So they say concentration of B in JDNQ. Remember, concentration we have in mole per DNQ and GDNQ. GDNQ is mass com, mole per DNQ is molar com. So B, com of B in GDNQ. Now, how do we get that? We have formulas for mass concentration to be mass over volume in DNQ. Of course, here there is no mass given. We also have mass concentration equals to molar com times relative molecular mass. Yes, maybe we can do that. This is the molar com of B and the relative molecular mass can be determined from here. So that is the second formula we use. You must get acquainted to the formulas. So this is equals to molar com of B times relative molecular mass of B. Remember, they are all anhydrous. So the molar com of B is 0.0258 mole per DNQ times the relative molecular mass of this compound is 106. But let's see how. Na2CO3. So if I come back here, 0.0258 mole per DNQ times sodium atomic mass is 23 times 2 plus carbon is 12, oxygen is 16 times 3. So this is okay, let me come back. 0.0258 mole per DNQ times 23 times 2
46
plus 12 plus 48 will give you 106 G mole. So now we move on. This time this will give us what?
2.73 GDNQ.
0.0258 times 106
Yes.
is 2.73
73
GDNQ of anhydrous B. So GDNQ of anhydrous is 2.73 GDNQ. Let me call it of anhydrous B. Alright, we're done with our B. Let's listen again. They say C, given that B contains, now they are bringing the hydrated, I think. Given that B contains 3.60 gram of the hydrated sodium triisocarbonate 4. Now, sodium triisocarbonate 4 hydrated, it means that that guy does not contain any water crystallization, so it's always the anhydrous. So now they say hydrated means that compound become Na2CO3 dot XHO, H2O. So this is now the hydrated compound of sodium triisocarbonate 4, that is anhydrous. Now they say contains that 3.60 gram of the hydrated sodium triisocarbonate 4 salt in 500 cm cube of solution. We should calculate the percentage of water of crystallization of the hydrated salt. Now 3.6 gram in 500. Did I write that down? No. So now the GDM cube of hydrated, GDM cube, which is mass concentration, 3.6 gram in 500 cm cube. Now remember, the formula says relative molecular mass of hydrated, if we want to start with, over the mass of hydrated equals to relative molecular mass of anhydrous over mass of anhydrous. So if we must proceed with that formula, we must also know the mass concentration of what they hydrated. And what is the formula for mass concentration? We also have that one that has mass over volume in DNQ, and the word of molar count times volume, molar count times relative molecular mass. So if we are using mass over volume here, this means these two variables can give us the mass count of the hydrated sodium triisocarbonate 4. So let's see how that works. I have to clean this so that I get the mass count of the hydrated, so I can proceed with the formula. Yeah. Now, mass count of hydrated salt or base, hydrated B, is equals to mass in gram over volume in DNQ. The mass is given to be, where is it? 3.6 gram over the volume is 500. In dm cube means we divide it by 1000. We call it dm cube. This is 3.6 gram over 500 divided by 1000.
0.5.
That's 0.5 dm cube. And this is equal to 3.6 divided by that.
7.2 GDM.
7.2 GDM cube. So this is the mass form of the hydrated salt. So let me put it here, 7.2 GDM cube. Now, let's apply our formula. I can clean this now, I'm done with that. So we want to get the percentage. They ask us directly to get the percentage. Remember, before you get the percentage, you must know the number of water molecules present in the sample. So I have my relative molecular mass of hydrated. Let me not be writing it. You know, the formula says relative molecular mass of the hydrated, which is that. Okay, let me start with anhydrous. It's the same thing. Relative molecular mass of the anhydrous, which is 106, over mass count of the anhydrous, which is 2.73. 73 is equals to relative molecular mass of the hydrated, which is 106 plus X18. Sorry, X18. I'm writing water. All over mass count of the hydrated, which is 7.2. So as usual, we cross multiply 2.73 open bracket 106 plus X18 close bracket is equals to 106 times 7.2. 2.73 times 106 is what?
289.38.
289.38 plus 2.73 times 18.
49.14.
49.14x is equals to 106 times 7.2. 763.2. Let me cross over here. Now, this is what I'm looking for. So I have to make this a subject by taking this across. So 49.14x is equals to 763.2 minus 289.38. 289.38. What do I get?
47.39.
47.39.
3.9.
473.
3.9.
3.9 when I get that. So I divide both sides by this. 49.14. 49.14. When this cancels out, I have x is equal to this divided by this.
9.6.
9.6 approximately 10. So the hydrated compound now become Na2CO3 10H2O. Sodium triosocarbonate 4 decahydrate because it contains 10 moles of water of crystallization. So now I've got to my X. Now they're asking us to get the percentage, which was the initial question they asked, but we can't get there without knowing what our X is. So now I have to substitute this directly. Permit me if I just have to use my 10. I don't want to use 9.6. Almost the same thing. Let's use 10 to get the percentage now. So I can calculate this now. Now, percentage of water of crystallization is equals to the mass of water, which is 1018, that's for water, over the total mass of this, which is 106 plus 1018 times 100. 10 times 18.
180.
180 over 106 plus 180
200.
times 100. This is 180 over 200 and what?
86.
86 times 100. Now, 180 times 100 divided by 286, what do you get?
62.9.
62.9%. The percentage of water in this compound, the anhydrous, was very high. Of course, you can see it's decahydrate. That is why our answer took us to 62.9%. So that's the end of question number 2.